Hi everyone, this is the fifth video, Introduction to Matrices, and this is probably the first time you've seen a matrix. Matrices is the plural for matrix. So we're going to define and describe them, and then I'm going to show you how to add, subtract, and multiply matrices. A matrix is a rectangular array of variables or constants that are arranged into rows and columns. So for instance, if I had a matrix that looked like this would have 2 rows and 2 columns. And so I would say this was a 2 by 2 matrix. The one up here you can see has 3 rows and 4 columns. So this is a 3 by 4 matrix. Each number is called an element. So the 8 is in the first row, first column. The negative 1 that they're talking about here, that element, is in row 2, column 1. So you would say that it had the position of A, 2, 1. Those subscripts would be row and column. And it's always in row and then column order, row and column. So for instance, if I have a 1 by 3 matrix, that's 1 row and 3 columns. So it would look like this. A 2 by 3 would be 2 rows and 3 columns. So each one of the numbers in there is a element of the matrix, and it says it can have numbers, but it can also have variables. You could have something like that, and that's also a matrix. So a matrix, when I want to name it, for instance, this matrix that's here in the example is called a capital A. An uppercase letter usually denotes a matrix. So this matrix might be B, and this matrix might be C. And so these are just a way of organizing, and you'll notice it has brackets on it. This is a way of organizing data, and it's been used for a very long time to organize data and also to analyze it. So we're going to show you just a few different ways of doing that. So adding and subtracting matrices, you need to have the same dimensions. So for instance, up here, you can see using just elements, A, B, C, D, using letters for elements, that if I have matrix A plus matrix B, right, then I would add each corresponding element together. So for instance, if I have 2, 3, 4, 5, this is matrix A, and matrix B is equal to 0, 1, 2, 3. Then if I wanted to add matrices A to B, then I would say 2 plus 0. Now, honestly, I would just write 2, but that's what's happening here. I have 2 plus 0, 2 plus 0, then I would do 3 plus 1, then I would do 4 plus 2, and 5 plus 3. So my actual matrix, after the math was completed, 2 plus 0, and then this would be A plus B. And I'm going to put equal signs between them because they mean the same thing. A plus B is this with the elements added. This is the final matrix. So it's pretty simple. Adding the elements together, adding matrices together, just adding the corresponding elements together. Subtraction is just adding a negative. So it's just as simple as it looks. You can see this example right here. And if you would write this example, plus the one I did in your composition notebook, that should be sufficient for that one. Okay, so here are 3 matrices. Here are 3 matrices. And so find each of the following for A plus B, B minus C, and B minus A. Now you'll notice that A and B are the same dimensions. So we have 2 by 2 and a 2 by 2. But C has 2 rows but 1 column. So if I wanted to add together or subtract, I would need 2 matrices of the same dimensions. So if I added A plus B, right, then I would look at first row, first column, that's 16 minus 4, which is 12, 2 minus 1, which is 1, negative 9 plus is negative 12, negative 9 plus a negative 3, and then 8 minus 7 is 1, and so that would be A plus B. If I were trying to do B and C, I cannot add them because they are different dimensions, so I can't add that one. But I could do B minus A, right? So I'm going to start with B, and I would say negative 4 minus 16, and then I would have negative 1 minus 2, I would have negative 3 plus 9, and I would have negative 7 minus 8. And so my final would be negative 20, negative 3, negative 15, and 6. And that would be B minus A. But I couldn't do B minus C because they are different dimensions. And so I have to have them the same dimensions. Okay, we can also multiply a matrix by a number. And they call that, if you just want to multiply, like on here you see 5R, they call 5R a scalar. So if I took like 2 times A, that would be 2 times every element in matrix A. So it's just as simple as it looks. So if I want 5R, then I'm going to multiply 5 times every element in that matrix. So I've got negative 60, 40, 30. I've got negative 80, 20, and 95, I think. Double check my math on that. But that would be 5 times every element. Pretty simple, huh? Okay, so now, given 2 matrices of the same dimensions, 3 rows, 2 columns, 3 rows, 2 columns, I'm going to find negative 6b plus 7a. So let's take this in pieces. So the first thing I'm going to do is I'm going to find negative 6b. So I'm going to do negative 6 times 12, which is negative 72. Negative 6 times 5 is negative 30. Negative 6 times 5 again is negative 30. And I'm just taking negative 6 times every element in here. And then I have 24, and I have negative 24, and I have 42. Okay? And then I'm going to add it to 7a. So I'm going to multiply 7 times everything in that. So negative 35, and 21, and 42, and negative 56, and 14, and 63. And then I'm going to add those two together. So negative 6b plus 7a is equal to what? So I want you to finish this problem, and I will see you in class.